Hey everyone, and welcome. Today, we're going to break down one of the really clever ideas in reinforcement learning, the n-step tree backup algorithm. Sound complicated? Don't worry, we're going to make it simple. Let's dive in. So, let me ask you a question. How do you actually learn something new? Think about a game of chess. Do you get better by analyzing every single move right after you make it? Or do you only really learn after the game is over and you see if you won or lost? This is the exact kind of puzzle that reinforcement learning agents are trying to solve. And that question leads us straight to a big trade-off in learning, a real dilemma between two very different strategies. Okay, so on one side, you've got what's called the whole story, or Monte Carlo method. This one waits until the entire task is finished, then it looks back at the real final outcome. It's super accurate, but man, is it slow. You have to play the entire game just to learn one thing. Then on the other side, you've got the next step approach, or one-step TD learning. This one is crazy fast. It learns after every single move. But here's the catch. It's short-sighted. You're basically updating a guess based on another guess, which can be pretty unreliable. So you see the problem, right? We've got these two extremes. One is patient and accurate. The other is fast but kind of impulsive. So what if we could find the perfect balance? A happy medium that gives us the best of both worlds? Well, that's exactly what n-step methods are for. To make this all feel really intuitive, let's use a simple real-world analogy. I want you to imagine you're planning a 4-day road trip. Your plan looks pretty straightforward. On day 1, you drive from city A to B. Day 2, B to C. Day 3, C to D. And on day 4, you're at your final destination. Believe it or not, this is exactly like an n=4-step look-ahead in reinforcement learning. We're not just looking at the very next turn, but we're also not waiting until the entire trip is over. Okay, but even with this 4-day plan, there are a couple of different ways you could update your estimate for how long the entire trip is going to take. And this is where things get really cool. Now, a simple planner would only learn from the exact route you took each day. If you took the highway from city A to city B, well, that's the only thing it cares about. It completely ignores all the what-if scenarios. But the tree backup planner? Oh, it's way smarter. It learns from the route you actually drove, sure, but it also considers all the other possible routes you could have taken from each city. Maybe there was a scenic route or some back roads. It then averages out the potential travel times of those what-if routes based on what it knows about your driving habits. And you'll hear this term backup a lot in reinforcement learning. All it means in our road trip analogy is updating our estimate. Simple as that. After you finish day 1, you have a much better idea of the total trip time, right? So you back up that new information to improve your original guess. This is why the tree backup planner is so much more efficient. It just squeezes more learning out of every single experience. It's not just learning from what you did, but from this whole rich tree of possibilities of what you could have done. And that makes it a much faster, much more robust learner. All right, so let's put this all together. How do these pieces actually work? Let's walk through the full itinerary for how tree backup operates. Okay, so here's the play-by-play. First, you take your action, you drive from city A to B. Now, when you get to city B, instead of just looking ahead to the drive to city C, the algorithm considers the value of all possible routes you could take from there, and it weights them by how likely you are to actually choose them. Then it does the exact same thing at city C and so on for all 4 of our steps. What you end up with is this branching tree of possibilities. So the final update to your estimate is this rich, weighted average of many potential futures, not just that single lonely road you actually took. And hey, don't just take my word for it. The legendary textbook on reinforcement learning by Sutton and Bardo says it perfectly. The key here is that phrase, use the state action values of the unselected actions. It's literally learning from the choices you didn't make. That's the secret sauce that makes this whole thing so powerful. So, after all that, what's the one thing you should absolutely walk away with from this explainer? Let's boil it all down. Here it is, plain and simple. Tree backup learns more efficiently because it uses the value of paths not taken to improve its guess about the future. It's all about learning from the roads you could have traveled, not just the one you did. It's a really powerful idea. And that kind of leaves us with a fascinating final thought to chew on. In a world that's filled with uncertainty, how much should we plan for the roads not taken? It's a great question. Thanks so much for watching.